See students, when we talk about the concept of global maxima, global minima, this concept is there in the end of differential calculus, but the main reason for taking it is to make you people understand that global maxima, global minima is nothing but range of the given function, right? Let us see. What we discussed on that day, I'll have a slight revision here. So we drew one graph, right? We took the function y is equal to f of x, and we assume that y is equal to f of x is a, one second, yeah, and we assume that y is equal to f of x is a what do you call it, a continuous function which is not breaking. So y is equal to f of x, x belong to square bracket a comma b, it belongs to square bracket a comma b. Then after that I told you how to define it. This is a, this is b. In between, we drew the function like this, right? And then we took the shadow of this function on y-axis. There was some turning point, smooth turning point, where you draw a tangent. Tangent will be parallel to x-axis. So this is the point C1. This is the point C2. This is the point C3. If you take the shadow of these on y-axis, this point will be f of b. Just a revision of what we did in last class. This is f of C3, this C3, f of C3. And you said the range is square bracket of f of b to f of C3, right? So whenever a function is defined to us in a given interval, that means in square bracket a comma b, it is defined, how to find the range we are going for. So the step one, first of all, make sure, here we'll take one theory that range, upper and lower part, yeah, global, this is in a to b, the maximum of the function is this, the minimum of the function is this. So we call it global maxima, we call it global minima. Global means in the entire a comma b, in its world. Global maxima is f of C3, global minima is f of b. So he says global maxima or global minima of any function, right? The contributors are, remember last Sunday, the contributors are either the endpoints a or b or the turning points. The turning points we call as critical point. Let us define critical points. Critical points. Critical point. No need to take, first understand it. Critical point. What are the critical points? Very rough idea I'm giving. It is not an original. That means there are a lot of hinge attached. A rough idea I'm giving. Critical points are those points where function takes a turn. Critical points are those points where function takes a turn. See, the function is going up, going up, going up, going up, going up. Then suddenly comes down. So goes up and comes down. There's a turn. The turn can be either, I told you now, sharp or sharp like mod x, right? Or the turn can be smooth like x square. You just assume both the graph. Y is equal to mod x. Y is equal to x square. In y is equal to mod x, there's a turn at 0. In y is equal to x square also there's a turn at 0. But there are two different turns. One turn is sharp edge. If you take that mod x and in that turn, if you take and put in your head, it will have a, you will get hurt, right? Whereas the smooth turn, it is a tangency. So at the sharp edge, make sure you cannot draw a tangent. Whereas the smooth edge, you can draw a tangent, right? And there in the turn, if the turn is smooth, the tangent drawn is parallel to x-axis. So such point where function takes a turn, we call as critical points. At those points, either f dash x, means first differential, either f dash x is 0 or f dash x does not exist. So we'll write here critical points. These are, no need to write, understand it. These are those points where f dash x is equal to 0, and I hope all of you understand the meaning of f dash x. F dash x means if you take y is equal to f of x, but dy by dx is called f dash x, right? Where f dash x is 0, that means tangent drawn is parallel to. What is the meaning of this? Tangent parallel to x-axis. Or f dash x does not exist. For this, we will discuss later on when we do continuity, differentiability and all. F dash x does not exist means, example I told you in y is equal to mod x, in y is equal to mod x, at sharp x, you cannot draw a tangent. So it may be a turning point. So first we define critical points. So for solving for the range of this kind of function, where lower point is given and upper point is given, then first and foremost thing what we're going to do, first is you are going to find the critical points, right? So critical points are those points where first differential is 0 or differentiation does not exist. This, right? First we are going to find the critical points. After this, after going for the critical point, what we are going to do? Try and understand. Suppose you, for this sum, this was y is equal to f of x. For this sum, you find f dash x. Tell me f dash x 0, f dash x is equal to 0 will give you what all points? F dash x is equal to 0 will give you what all points? This will give me those points where tangent drawn is f dash x आपने 0 किया. You did f dash x 0. In this curve, see, f dash x 0 means tangent parallel to x-axis. Okay. So this point you will get tangent parallel to x-axis. This point you will get tangent parallel to this. So this C1, C2, C3, this C1, C2, C3 turning points you get from f dash x 0. So you get x is equal to C1, C2 and C3, right? So how do you see A and B is given to you? How to get C1, C2, C3? Put f dash x is equal to 0, find C1, C2, C3. Uske baad you find now what all values you have? You have x equal to end points and these points. So he says global maxima or global minima of any function can exist either at the end point or at the critical points. Only these are the culprits. Either A will be maxima or A will be minima, or B will be maxima and B will be minima, or C1, C2, C3. So what you'll do, you find f of A, you find f of B, you find f of C1, you find f of C2, you find f of C3. Out of these 5 values, what is f of A? A पे function की value, A पे function की value f of A. F of C1, F of C2, F of C3, F of B. Out of these all, whichever is maximum is called global maxima. Whichever is minimum is called global minima of this function in square bracket A, comma B. So this particular graph you take and this you write, I'll delete it off, then we'll go for summary. Please take it down. We are going for range of same continuation of the last class, range of function square bracket A comma B. This extra graph you make, critical points you define, and then here you can write this here. So this theory we will use. Global maxima or global minima will exist either at the end points of the domain or at the critical point. So for this function, maxima minima can exist either at the end points of domain, at A, at B, or at the critical points. What a critical point? F dash x 0. What is that? X equal to C1, C2 and C3.